So today we start a new chapter, and it is the most important and most interesting chapter. The chapter is particle of matters. Means particle of matters means इसको क्या कहता है? Rotational dynamics and center of mass all is there. Okay. So especially just one. We generally say this chapter rotational mechanics, but actually this is the in this chapter you have two chapters basically, or you can say it's a combination of two parts. First part is the center of mass, and second part is the rotational dynamics. So my main aim is for today's class is center of mass. Okay, so it's a I think chapter number 7. And today we start that part is called the center of mass. Okay. अब देखो पहला बात है, सबसे जो पहला बात है कि from the name we can understand so many things, yes or no? So what do you mean by center of mass? कि सब mass का एक point where the total mass is concentrated means what do you mean by that? See, और इसका जरूरत क्यों है? Suppose we have a irregular shape object, okay, and if you want to move that object from that point to another point, I'm trying to draw exactly same. I don't know I'm able to draw it or suppose I'm trying to move it from this position to this position, okay, and in this object, how many particles you have? You have infinite number of particles, yes or no? Yes or no?
Yes, sir.
Sir.
So if you want to show that the particle is moving, that means you actually have to show all the particles are moving. And when you show all the particles is moving, so it will take your all time, yes or no? So that's why instead of that, if I'm trying to find out a position, instead of that, if I try to find out a position where the total mass of the particle is concentrated, and we not represent m1, m2, m3, we represent the total mass concentrated at that point. So we can say if the particle is moving like this and then this, the center of mass is moving like this and this. What do you mean by that? The initially the particle moving upward, then downward, then upward, then down, right? Yes or no?
Yes, sir.
So that means center of mass is what? Center of mass is a position of a particle where the total mass of the particle is concentrated. Yes or no? Everyone understand?
Yes, sir.
So once you find out that position, if you differentiate that position with respect to time, you get the velocity of the particle. If you differentiate with respect to time again of that particle, you can get the acceleration of that particle. If you multiply it by the total mass, you can understand how much force apply on the particle and all these things. So we can calculate all these things once we able to find out where the exactly the mass is concentrated. Clear, everyone?
Yes, sir.
So my main aim to find out the position where the total mass is supposed to be concentrated. So for that, a very, very important question is that the question is given in that way: find center of mass of a system of particle. Find the center of mass of system of particle. Okay. Basically, to find out this, we start with two particle system. Okay. So suppose this is my three-dimensional plane. Three-dimensional plane means this is the x-axis, this is the y-axis, and this one is the z-axis. and this is the origin. We have two particles of mass m1 and m2 at position r1 and r2. Okay. Now, as you have two particles, so obviously there is a intermolecular attraction between the two particles is present. Let force at 1 due to 2 and force at 2 due to 1. There is an internal force, that is in terms of gravitation, you can say, in terms of potential energy, in terms of their structure. So this is the force of 1 2 and force of 2 1. They are equal and opposite. So we can say force at 1 due to 2 and force at 2 due to 1 equals to 0. So now we are apply some external force F1 and F2. We are applied to external force on that system. So now how many force we have? 4 force, F1, F of 1 2, F of 2 1 and F of 2. So we can say force net force, that is force of 1 plus force of 1 2 plus force of 2 1 plus force of 2. Now out of this 4 force, these two force balance each other because the net value is 0. So my net force is F1 plus F2. Everyone, you satisfy up to this?
Yes, sir. Yes, sir.
So now as my force is F1 plus F2, now what do you mean by F1? M1 A1 plus M2 A2. Now what do you mean by A1? M1 A1. What do you mean by A1? We know acceleration means velocity with respect to time. So we can write dv1 by dt plus m2 dv dt by dt. Just give me one. So, and we also know velocity, that is dr by dt. Yes or no? So we can write m1 dr1 by dt on a velocity differentiation of velocity. Displacement with respect to time is the velocity plus m2 dr2 by dt. So that is equals to m1 d square r1 by dt square plus m2 d square r2 by dt square. That means what we can say, d square by dt square is m1 r1 plus m2 r2. Everyone, is it okay? See, basically it's a very simple thing.
Yes.
Don't think it's a very complex. No, it's a very simple. You have basically two force, F1 and F2. You apply externally. Rest, as you have two particle system, so some internal force also present, may be present. So that is force of 1 2 and force of 2 1, because like gravitational force is also internal force. So as you have two particles, so you may have some gravitational force also. You can neglect it, but maybe it present. So we can take it F of 1 2 and F of 2 1. But as it is a two particle system, so they are equal and opposite, so they cancel each other. So I can say that part is 0. So my actual force is F1 F plus F2. Now as you have two force F1 plus F2, what is the formula of force? Mass into acceleration. So in the next step we write m1 a1 plus m2 a2. Why? Because two different particles. Now what do you mean by acceleration? Velocity by time. Yeah, rate of change of velocity. So m1 dv1 by dt, m2 dv2 by dt. Now we know velocity is the differentiation of position with respect to time. So again we differentiate, or indirectly we can say कि acceleration is the double differentiation of position 1 and position 2. Why? Because you have two particles. So we remove that double differentiation term d square by dt square. So we have m1 r1 plus m2 r2. Although we can't differentiate m1 and m2 because m1 and m2 are constant here. So here the variable is position. So obviously differentiate the position. Yes or no, everyone understand?
Yes, sir.
So once you differentiate this, after that, I can say, okay, I can arrange it m1 plus m2 d square by dt square m1 r1 plus m2 r2 by m1 plus m2. I can multiply it by m1 plus m2. I can divide by m1 plus m2. It will be no effect. So let it be my first equation. And that is actually the net force applied on the two particle system whose masses are m1 and m2 and position are r1 and r2. Yes, everyone? Okay.
Yes, sir.
Now, what is the definition of center of mass? Center of mass is defined as a position where the total mass is concentrated. So let RCM is the center of mass of the system. You can say of the system, you can say of the two particle system because you are using two particles. It's overall same thing. So if RCM is the center of mass of the system, total force is m1 plus m2 because you have two particles, and we know that double differentiation of position is called the acceleration. Yes or no? বিবেকের কি হলো, বেচারা জয়েনই করতে পারছে না। Everyone, you understand?
Yes, sir.
So now see, in both the equation, that is the first one, that is your total force, that is m1 plus m2 double differentiation of m1 r1 plus m2 r2 by m1 plus m2, and the second one, that is m1 plus m2 double differentiation of position. They are the same thing, and if they are same thing, so see m1 m2 m1 m2 by comparing are d square by dt square, d square by dt square. So by comparing 1 and 2, by comparing 1 and 2, we can say our center of mass, that is m1 r1 plus m2 r2 by m1 plus m2. Everyone okay? Can we write this?
Chapter পড়াচ্ছো?
Center of mass, chapter 7.
Okay, sir.
Rotational dynamics. Chapter tar actual naam jane ki besh? Ki rotation particle.
System of particles and rotational motion.
Particles. Very good. এই জন্য তো এই ছেলেকে আমি এত ভালোবাসি। System of particles. Hello. Everyone, you understand? Hello.
Yes.
Acha. Now see, this is for two particle system. So first we find out for two particle system, and then we can say for n number of particles. Now we going to write it for the general form. For n number of particles of mass m1 comma m2 dot mn, of positions R1, comma R2, comma, they all are vector, huh? Rn, because we know position is a position vector. So our center of mass is শুধু সারি দেবে দরজাগুলো খোলো, জানাটা পাট করে খুলে যায়। M1 R1 M2 R2 dot 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 Mn Rn by M1 plus M2 dot 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 Mn. Okay, everyone. System of particles আমার মাথাতেই আসছিল না কিছুতেই। Done, everyone?
Yes,
So,
sir.
this is a derivation which can ask in your school exam, and which can examiner can give you 3 to 5 marks. Okay, so this is a very, very important derivation. An examiner can give you 3 to 5 marks for that. They can give you in more elaborate form T2 particle of mass M1 and M2 placed at position R1 and R2. Find the center of mass of the two particle system, or they simply say you find the center of mass of the particle. So if they say you two particle system, you write up to this. If they say you find the center of mass, so you have to add one more line, that is that much. Clear? Is it okay?
Yes, sir.
Now from that we can deal, or we can generalize so many things. So let's see. First of all, as R1, R2, R3, they are the position. So we can say as R1, that is X1I, Y1J, Z1K, R2, that is X2I, Y2J plus Z2K, dot 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 Rn, that is Xni, Ynj, Znk. If you write in that way, R1, R2, R3, R4 dot 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 Rn, then what is your R center of mass? That is M1 X1I, Y1J, Z1K, M2 X2I, Y2J, Z2K, dot 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 Mn Xni, Ynj, Znk by M1 M2 dot 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 Mn. So basically what happened? Okay, you can say that is equals to M1 X1, M2 X2 dot 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 Mn Xn by M1 M2 Mn I plus M1 Y1 M2 Y2 Mn Yn by M1 plus M2 Mn J plus M1 Z1 M2 Z2 Mn Zn by M1 plus M2 dot 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 Mn K. Yes or no, everyone? Everyone, yes or no? Can we write this?
Yes, sir.
So if we can write in that way, so we can now segregate x-axis, we can segregate y-axis, we can segregate z-axis. And what do you mean by the R? R is a position. So for any position, you must have x-axis, x-axis coordinate, or x position. You must have y-axis position. You must have z-axis position. So this one, we can say x center of mass, which is m1 x1, m2 x2, dot dot dot, mn xn by m1 plus m2, dot dot dot, mn. I represent x-axis. We can write it in terms of summation mi xi by mi, or else we can write this the downward m1 plus m2 up to mn. The total mass is m, and that sum up, what do you mean by sum up? Sum up is the integration symbol. This is for discontinuous object. Mane, if you have suppose 5-point particle are placed at the different point, then you use this one, sum up, this symbol. Okay, but if they are continuous object like a rod, ring, disc, so then as it is a continuous object, you can use the symbol, this integration symbol, and then 1 by m. M is the total mass, m is the, and this small m is the position, so dm, very small mass, and x is the position. We not write it dx because that position is not small. That position can be a large position also. Like I just say you, suppose this is a particle which is rotated with respect to that position, that axis. So we can take a small mass dm, which is at a distance x. So try to understand, mass is my small, but distance is not very small, not necessarily small. So we can use x. Clear, everyone? That x is not dx because that x is not small value. Clear, everyone? Yes, everyone?
Yes, sir.
So mainly in entrance we use this one. Still rare part. माने especially engineering में IIT वगैरह में use करते हैं. But otherwise most of the numerical we solve it by this formula. Okay. So similarly, if we try to write for y-axis, if we try to write for z-axis, same manner, same way we can write them. So if we want to write for y-axis, y center of mass, we can write m1 y1, m2 y2, dot dot dot, mn yn by m1 plus m2, dot dot dot, mn. That we can write summation mi y I by mi, that is 1 by m dmy. Similarly, if you want to write the z center of mass, so we can write m1 z1, m2 z2, dot 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 dot, mn zn by m1 plus m2, dot dot dot, mn, that is mi zi by mi, that is total mass integration of dm z. Clear? And this is the, you can segregate them with respect to x-axis, y-axis, and z-axis. But if you want to write them the overall, although it's a very rare, you don't need this, but still, if you want to write, okay, mi ri by summation mi, which is very rare, 1 by m integration of dmr. Sometime if maybe you require this, so I can, it's better I can write the formula. Otherwise you say, so from where you get this formula? So you can write the general formula also, but mostly we use this 3 formula for x-axis, for y-axis, and for z-axis. I think you realize it's a very tough thing, but believe me, it's a very, very simple thing. It look like very tough thing, but actually it's a very simple thing. Everyone, is it okay?
Yes, sir.
So let's discuss some numerical. Once you discuss numerical, then you realize how interesting they are and how easily we can solve numerical related to that. So my first numerical related to center of mass chapter or a system of particles chapter. The first question is that you have a xy coordinate. This is my x coordinate. This is my y coordinate. And in this xy coordinate, three particles are placed, one at here, one at here, one at here, at three vertex, A, B, C. So distance between A and B is 1 meter. Distance between B and C is 1 meter. Distance between A and C is 1 meter. Okay. So here the mass is 1 kg. Here the mass is 2 kg. Here the mass is 3 kg. Now the question is find the center of mass of the system. So you try this question or first question I show you? Hello. Okay, at least you try them. I give you.
Yes, sir.
So this one is 0, 0. This one is 1, 0. Anyone tell me what about that coordinate? 0 and 1 half. अब देखो इसका height कितना हो जाएगा? You can take it in two way. You can take it in that way. ये मेरा अगर origin है D है, that is half comma 0. So this is 1, this is half. So I can use it as a 1 square minus 1 by 2 square. That is root 3 by 2. This is the one way I can calculate. Another way is AD is AB. That angle is how much? 60 degree, right? Because equilateral triangle AB sine 60 degree. So what we can write 1 into root 3 by 2 direct. So root 3 by 2. So my coordinate is root 3 by 2. Clear, everyone? Everyone, is it okay?
Yes, sir.
So once you get this coordinate, now my x center of mass. What is the formula? M1 we start from, suppose here. We start from here. M1, what is my M1? 2 kg into my coordinate is 0, x coordinate. Then we have 3. My x coordinate is 1. Then we have 1. My x coordinate is half by 2 plus 3 plus 1. So what we have? 3 plus 1 by 2. 3 3 6 7 7 by 2 and here 6. So 7 by 12 meter. Similarly, y center of mass, that is 2 into 0 plus 3 into 0 plus 1 into root 3 by 2 by 6. So what we have? Root 3 by 12. So my RCM, that is 7 by 12 meter, comma root 3 by 12 meter. I can write in that way, or I can write in that way also. This is the coordinate form I can write, or we can write R is equals to 7 by 12 I plus root 3 by 12 J meter, है ना? Coordinate or position. Understand, everyone? Everyone, is it okay?
Sir, I have one question.
Huh?
Sir, I have one question. एक चीज समझ में नहीं आया सर, ये सब हम लोग कोऑर्डिनेट कैसे खोजेंगे? पॉइंट ए, पॉइंट बी और पॉइंट सी का 0 0।
हाँ, अरे देखो ना, ये 1 मीटर है ए का बी. क्वेश्चन में गिवन है ए बी सी आर 3 वर्टेक्स which are 1 meter separation, right?
यस सर.
1 1 1. So अगर मैं इसको 1 origin मानता हूँ, इसके रिस्पेक्ट में इसको 1 0 मान सकता हूँ ना?
ओके सर.
और फिर इसका ये मिडिल पॉइंट है, तो इसका हाइट निकल गया. सो एक्स एक्सिस और वाई एक्सिस निकल गया, तो कोऑर्डिनेट आ गया ना?
हाँ सर, ठीक है.
Now I'm going to give you one more question and you please try this question. कभी-कभी मुझे भी check करना पड़ता है कि it's recorded or not. The next question is, see, second question जो है, that is question में given है a L-shaped lamina, ठीक है, किसी किसी में रहता है ये equal mass, किसी किसी में रहता है the mass is 3 kg. So if the total mass of that lamina is 3 kg, you have a L-shaped lamina. In some question they give you the mass is m, or in some question they give you the mass is 3m. Okay, suppose the mass is 3 kg. So length is 2 meter. This is the x coordinate, this is the y coordinate. This figure is they given you. Okay, this figure they given you. This one is 2 meter, this one is 1 meter, this one is 1 meter, this one is 1 meter, and this one is 1 meter. Okay, mass is uniformly distributed. So question is find total mass of the L-shaped lamina is 3 kg. Length is 2 meter, 1 meter, 1 meter, 1 meter, as shown in the figure. Find center of mass of the L-shaped lamina. L-shaped lamina. Okay, try this question. See, first of all, एक चीज तो यहाँ से पता चल रहा है, देखो ये 3 पार्ट में डिवाइड है ना? Yes or no?
Yes, sir.
So I can suppose this is as one center, this one as another center, इसको एक और center. So let it be C1, let it be C2, let it be C3. तो अब देखो कोऑर्डिनेट के हिसाब से इसका कोऑर्डिनेट क्या होना चाहिए, बोलो? अगर ये 2 है, so यहाँ तक क्या होगा 1, yes or no? तो इसका हाफ कितना होगा, हाफ? Yes or no?
Yes, sir.
यस सर.
इसका हाइट कितना होगा, 1 का हाफ, तो हाफ है ना?
Yes, sir.
इसका कोऑर्डिनेट क्या होगा? बोलो, कोऑर्डिनेट करना मेन है. ये 1 है, ये 2 है, तो इसका बीच में ये क्या होगा?
1.5.
1.5 माने 3/2. इसका क्या होगा?
Half.
हाफ. वेरी गुड. इसका कोऑर्डिनेट क्या होगा? एक्स एक्सिस में हाफ ही होगा,
2.
होगा ना? और वाई एक्सिस में देखो 1 और 2 के बीच में, तो कितना होगा?
3/2.
3/2. Everyone understand?
Yes.
Everyone, is it okay? So what about my x center of mass? X center of mass is all, it's an overall it's a 3 kg, so I can suppose 1 kg, 1 kg, 1 kg. So if we start from this one, C1, the total mass is 1 kg and my x coordinate is half. This one is 1 kg and x coordinate is 3/2. This one is 1 kg and x coordinate is 1/2. By mass 1 plus 1 plus 1. No? So what we have, 3 और 4 और 5, 5/2/3, that is 5/6 meter, है ना?
Yes, sir.
अच्छा देखो, मैंने तो ये मीटर में दे दिया है, तो आसान हो गया. Sometime they can give you in centimeter also. This 1 meter they can give you in 10 centimeter. This one is 20 centimeter. So you can write that 10/2 centimeter माने 5 centimeter. So you can cancel this in centimeter also. Then your result is also in centimeter, है ना? If they give you in centimeter, don't need to convert it into meter. You can write in centimeter. The value is in centimeter. Mass must cancel out, है ना? And sometimes they give you that length in meter and this mass is in gram. So if they give you in gram, upper wala bhi gram, niche wala bhi gram, gram cancel. So you don't need to worry about that, or you don't need to convert them if they all masses are in gram. So you can write it in gram and then cancel it, right? Similarly, Y center of mass is how much? Y center of mass is 1.
5 by 6.
Yes. 1 into 1 by 2 plus 1 into 3 by 2 by 3. That is 5 by 6 meter. So my R center of mass is 5 by 6 meter, comma 5 by 6 meter. Got it, everyone? Everyone, is it okay?
Yes, sir.
Now I want to give you one more question. My next question. You have a disk. Okay. This is the center. Y-axis, x-axis. So I can write it origin. And the radius of the disk is capital R. Now from this disk, you cut out a disk whose radius is R by 2. Cut out. Okay. So the question is, what is the center of mass of the remaining disk? Are you getting my question? The mass is uniformly distributed. Clear, everyone? Everyone, is it okay? You understand the question? From a disk of radius capital R, a disk of radius R by 2 cut out. What is the center of mass of the remaining disk? Clear?
Yes, sir.
So देखो ऐसा क्वेश्चन को क्या करना है, सबसे पहले तो मेरे को जब ये डिस्क मानो जो हमने कट आउट करके निकाला है वो नहीं था, सो मेरा सेंटर कहाँ पे था? ओरिजिन पे। और जिसको कट आउट करके निकाला उसका सेंटर क्या है? R by 2, 0. Yes or no?
Yes.
Because both the center are on the x-axis, so you don't need the y-axis because y-axis 0, 0. So the final center of mass is also in the x-axis. That I can say from the data. Now, as they don't give you the total mass, so we can suppose let the total mass is capital M. Yes or no? Everyone, is it okay? And let the mass of the cutout disk is a small m, which we have to explain in terms of total m. So we can write mass of cutout disk in terms of total mass. Small m is total mass is m. Yes or no? Total mass is m. You understand? The total mass of the disk is m. Yes or no?
Yes, sir.
And here you realize one thing, how you find out the mass of the cutout disk in terms of total mass. So here the mass is distributed area wise because 3 type of distribution is there. One is the mass per unit length, one is length wise distribution, one is the area wise distribution, another one is the volume wise distribution. Here it is area wise distribution. So what is the total area of the disk? Actual disk, pi r square. Yes or no? Everyone, yes?
Yes, sir.
So what we can write, capital M is the total mass per unit total area. So what we have, mass per unit area into area of the cutout portion. What is the area of the cutout portion? Pi r whole square. So then we get the total mass M by 4. So that means if capital M is the total mass, mass of the cutout portion is M by 4. Yes or no? Yes or no?
Yes, sir.
Yes, sir.
So what is my center of mass? Total mass is M for x-axis. My total mass is capital M. the overall one, the bigger one, the center is 0. Now we add or remove that mass. Cutout mass means we adding the mass or removing the mass.
Removing.
So we can write minus m by 4, and the position is r by 2 by total mass minus, because we are removing, m by 4. So what we have, minus mr by 8 by 3m by 4, and you can see this cancel. That's why they maybe sometimes they don't give you the total mass. Even they not mention the total mass is capital M. You can suppose in your own way and you cancel it. So what you have, minus r by 6. Yes or no?
Yes, sir.
And y center of mass, directly you can write 0 because both coordinates are 0. So basically what do you mean by that? That mass is shifted towards this side, है ना? So your center of mass is minus r by 6, 0. Yes? Everyone, yes?
Yes, sir.
Yes, sir.
Now in the same question, suppose in the same question, instead of they cut out, suppose they say ki we are adding a same material, radius is r by 2, and this one you extra
Then we
add.
have to
Yes,
add it, sir.
yes. So then my x center of mass is m into 0 plus
M by 4.
4 into r by 2 by m plus m by 4. Got it? So what we have,
Yes, sir.
m r by 8, 5 m by 4, m again cancel. So you have r by 10. So what do you mean by that? R center of mass is sorry. R center of mass is r by 10, 0, na?
Yes.
So
Yes,
what
sir.
we realize ki center of mass is shifted where you have maximum mass, right? माने जिधर mass ज्यादा होगा, center of mass उधर shift करेगा. Yes or no? Yes or no?
Yes, sir.
हाँ? अच्छा, don't go. I just want to. You all can see me ना?
Yes, sir.
अच्छा देखो, मैंने ये जो बॉटल लिया है, इसमें पूरा अभी पानी भरा हुआ है. So if I say where is the center of mass, तो देखो इस बॉटल, obviously it's a not regular shape bottle, नीचे का पोर्शन में ज्यादा पानी का शेप है, means the shape is थोड़ा thicker है और इधर थोड़ा thin है. तो अगर मुझे इसका बोलेगा कि where is the center of mass, अगर मैं बोलता हूँ लगभग ऐसा एक जगह पे टोटल सेंटर ऑफ मास होगा, मतलब इसके अंदर में कहीं पे, यहाँ पे इसके एकदम बीच में, मिडिल पे, इसका एक्सिस का बीच में लगभग ऐसा कुछ पॉइंट पे. Yes or no? You understand?
Yes, sir.
पॉइंट का अंदर है ना? Yes or no? Yes or no?
Yes, sir. Yes.
Yes,
तो
sir.
मैं इसको उंगली से ऐसे किया कि इसके अंदर वाला पॉइंट है. So now I just want to show you something. अब मैं इससे क्या किया, कुछ पानी पी लिया. अब अगर तुम्हें कोई बोलेगा where is the center of mass, अब तुम्हारा सेंटर ऑफ मास किधर होगा?
सर नीचे.
नीचे की तरफ. क्यों? क्योंकि
सर
देखो
शिफ्ट होगा
खाली
मास.
है,
यस सर.
मास नीचे की तरफ शिफ्ट किया.
यस सर. यस सर.
अंडरस्टैंड ना?
हाँ सर, समझ गया.
मैं और मास को हटा दिया. अब देखो ये यहाँ पे आ जाएगा, मतलब ज्यादा मास जिधर होगा, एकदम खाली कर देगा तो फिर ये ऊपर की तरफ आ जाएगा. क्यों? अब तो पूरा मास ही नहीं है, अब तो इस बॉटल का सेंटर ऑफ मास कहाँ पे है? तो यहाँ पे अभी इसका मास प्लस बॉटल का मास मिला के लगभग यहाँ पे है ना?
यस सर.
So try to understand what is my point. My point is my center of mass उधर होगा जहाँ पे टोटल मास का कंसंट्रेशन ज्यादा होगा, है ना?
Yes, sir.
So that's why in this question, when I show you ये वाला, देखो ये खाली पोर्शन है, तो खाली जगह पे कभी सेंटर ऑफ मास नहीं होगा, सेंटर ऑफ मास होगा जिधर मास है, तो ये इधर शिफ्ट किया, और फिर जब मैं इसमें आया, देखो यहाँ पे इधर ज्यादा मास है, तो सेंटर से ये इधर शिफ्ट किया है ना, देखो पॉजिटिव, यार ये है नेगेटिव, अंडरस्टैंड?
Yes, sir.
So this is the best part of center of mass, and in that way once you get the center of mass, then it's very easy to rotate it. माने जो हमारा जो chapter is system of particle, where we rotate a particle with respect to a center of mass or any other point. Mostly sometime we rotate it with respect to the center. जैसे देखो अगर इस बॉटल को मुझे घुमाना पड़ेगा तो मुझे ऐसे करके घुमाना है ना, सो इसके सेंटर से जो एक्सिस ले जाएगा which will passes through the center. हाँ,
Yes, sir.
so for that center of mass is very important. इसका एक और पार्ट है जो हम लोग नेक्स्ट क्लास में देखेंगे, where we show you the conservation of momentum, acceleration, force, so many things, and then we move on to the next part, that is the system of particles का जो next part है. तो एक और मुझे क्लास चाहिए होगा with related to that.
Sir, 1 मिनट स्लाइड दिखा सकते हैं?